Hi Sec Force. So now we'll learn how to annotate the predicle together. So once you know how to annotate, you'll be able to identify the test and why are we asking you to do certain things. So once you know this trick, every predicle will be as easy as that. So let's start. So you're provided with three solutions X, Y, and Z, and between them, these three solutions contain two different sodium salts. So what does it mean? It means that one of the sodium salt is sodium something and the other one is sodium something as well. And you're also provided with a solution P. So we look at P laterwards. So carry out the following tests. So all these are tests, and actually these tests there's a rationale behind each step. So later we'll go through in detail. So you should test any gas involved. That means if you see gas form, you need to test for it. So how do you know what to test for and which gas to test for? So you need to follow me and annotate on your own practical book as well. Alright? So whenever they say gases, you need to look out for effervescent. But whenever we see gas form, right, we need to prepare the setup before you carry out the step, because once the gas is produced, it'll be hard for us to get back the gas again. So we need to prepare first before we do. And sometimes they might ask you to identify any gases that's formed. So in this case, you need to name the gas in the observation. So we'll go through that when we see this question, alright? So the volume given below are approximate, and you should only estimate it. That means roughly will do, don't need to be so accurate. Unless they ask you to measure, then you need to be accurate. Alright, let's start. So they ask you to label 3 test tube X, Y, and Z and add 1 cm cube of these 3 solutions into the test tube. Okay, so this is the instruction. And you're asked to add dilute nitric acid slowly to each test tube with shaking until no further change is seen. So this one, no further change, I can write down. It means adding excess. Cause you keep on adding it until you see no further change. That means you don't know how much to add. So in this case, you're adding excess. So whenever they ask you to add dilute nitric acid, actually what's happening over here, they are actually testing for a certain type of ions. And they are anion. How do I know? So normally when they ask you to add acid, right, it's guaranteed that they are asking you to test for anion. So let's look at the QA table. So you can look at your own QA table as well. So for first thing, if you notice carbonate, they ask you to add dilute nitric acid. When it's chloride, they ask you to add acid as well. When it's sulfate, they ask you to add acid as well. So for whole of this table over here, right, whenever they ask to add acid, it's mostly to test for anion. Alright, and in this case, they only ask to add dilute nitric acid. So in this case, since we're adding only dilute acid, we are testing for carbonate. So when we are testing for carbonate, right, that means we need to look out for effervescent. And when there's effervescent form, in order to confirm that this is carbon dioxide gas, we need to bubble the gas through lime water. So if you look at the table below, carbon dioxide gas, if the gas is carbon dioxide, it will give white precipitate with lime water. Alright, so how to make that happen? You need to bubble the gas through lime water, and this also means that you need to prepare the lime water setup first before you mix the chemical. Otherwise, when the carbon dioxide gas produced, it will be too late for us to do the test because all the gas will have escaped. Alright, so you need to prepare first. So whenever you see white precipitate form, right, over here for the carbon dioxide gas, just a little bit will do. If you see a little bit form, that's enough already, because at the end of the day, you're not going to show the examiner that, oh, this is a white precipitate. It's only for your own observation, for yourself to see only. So once you know that, oh, there's white precipitate inside, that means that this gas must be carbon dioxide gas if I see this result after using this test. Alright, so shall we write down? So write down here, test for carbonate. Alright, test for carbonate. So please write it down, because if you write more and more times, you notice that actually all the practical, right, all more or less the similar one, because all of them are the same. Next, you are asked to keep the content for X, Y, and Z for part A, part 2. That means after you add the nitric acid, then you need to keep this one to use for part 2. Alright, you need to use for part 2. And some of you might have spot out, does it mean that I have to do this lime water test for every X, Y, and Z? So how do I know when to use it or when not to use it? So the key idea here is, if you see effervescent, there might be a possibility that this might be carbon dioxide gas. But if you see no effervescence, then do you need to test for it? No, right? Yeah. So don't test for it. So if there's no effervescence seen, then you don't need to waste your time to go and test for it. Alright? So no effervescence, no need test. Then you can save your time. Okay, let's move on to the next one. So in the next step, they ask you to add more dilute nitric acid until it's half full and shake the test tube. And after that, they ask you to add barium nitrate solution and shake the mixture. They ask you to add acid. They ask you to add barium nitrate. So what are we testing for? So let's go back to the QA table and take a look. We have acid and we have barium nitrate. Oh, they're asking you to test for sulfate. So if sulfate is present, you should see a white precipitate form. So shall we write down? So this step over here, we are testing for sulfate. So for sulfate, there are two outcomes. So if there's white PPT form, you write white PPT form as your observation. If there's no white PPT form, then you put no PPT form. Because we are trying to answer it using this test, because one means white PPT form, the other one, the opposite one will be no PPT form. Alright? So after you conduct this test for X, Y, and Z, then you'll be able to deduce what are the anions that are found in X, Y, and Z. Alright? So you're looking at sulfate and carbonate. Because this is what the test asks us to test for. You cannot test for other things because they never show the step for other things. Alright? Next, they will ask you to write down the evidence for your observation to support the two anion. So in this case, let me teach you a sure win strategy to score full marks for such things. So see, if you see 2 marks, right, that means you need to answer each of the thing correct in order to get the 1 mark. So one of them will be carbonate. Okay, so you can write down carbonate. The other one will be sulfate. Okay, so because this is what the test asks us to test for. Alright. So how do you write? First thing, you need to write in which test. So in this case, test A part 1, it asks us to test for carbonate. Alright. So you write down in test A part 1. So when you're writing this in test A part 1, you are already telling me the procedure for the entire test in this part, so that you don't need to waste time to write down the long sentences of the whole procedure. So this helps you to save time. So I have already written down in which test, done. So now you need to write down what did you observe. So in this case, since you're testing for carbon dioxide, right, that means that we should observe carbon dioxide gas produced, and in order to see the carbon dioxide gas produced, we should see a white precipitate form. Alright, so they will go through that afterwards. And so let me write down for example. So carbon dioxide gas is produced as white PPT is formed with lime water. So once you're done, then you need to tell me what does it tell me. So it tells me that, so this confirm the presence of carbonate ions. So this is how you write. So first part, in which test, so that you can skip and save your time to write down the whole procedure. So in which test, and next, you need to write down your observation. What do you observe? So carbon dioxide gas is produced, and how do we know that this is produced? Because of what we observe in the test. because white PPT is formed with lime water. And then what does it tell us? It tells us that this confirms the presence of carbonate ions. So these are the 3 steps to write down the evidence to confirm presence of ions. So once you follow this method, you can use this for cation, anion also can. So next, the next one. So the next anion they ask us to test is the sulfate. So same thing as well. So let's write down. So in test A part 2, how do we know that sulfate is formed? Because of what we observe. So what do you observe? We should observe white PPT is formed. So what does it tell us? It tells us that this confirms the presence of sulfate ions. So you either can write in words or you can write it in chemical formula, both are accepted. Alright, so we have done with part A of the experiment. Let's move down. So in B part 1, let's read the procedure again. So now we need to use solution P. Okay, so first step, add 1 cm cube of solution P into a clean test tube. Alright, then next, they ask us to add sodium hydroxide slowly with shaking until no further change is seen. So if you recall, right, sodium hydroxide, what does it ask us to test for? So let's look at the QA table. So if you notice, mostly when they ask us to test for cation, we are mostly adding alkaline, either sodium hydroxide or ammonia. Alright, so only there's one case whereby they ask you to add sodium hydroxide, which is to test for anion. There's only one way, which is the nitrate. They ask you to add sodium hydroxide and aluminum foil. So this one is quite obvious. So whenever you see alkaline and aluminum foil, right, definitely is nitrate. There's no other things really. So the aluminum foil is quite obvious. Alright, so back to the questions. They ask us to only add sodium hydroxide. So in this case, we are testing for cation. Alright, so we are testing for cation. So let's write down. So over here, we are testing for cation. Test for cation. And they ask us to add until no further change is seen. This means that we are adding in excess. Adding in excess. Because they ask us to add, and we don't know where to stop. So when we don't know where to stop, this means adding excess. Alright. Next, they ask us to add sodium hydroxide again, and then this time around they ask us to gently heat it. So if you notice, right, sodium hydroxide and gently heat. So let's look back at the QA table. So which one do they ask us to add sodium hydroxide and gently heat? Okay, I believe you have noticed it. So if you look at ammonium ions, ammonia produced on warming. Alright, warming. So if you see sodium hydroxide and warm, this is to test for ammonium ions, which is also cation. Alright. So how do we make sure that this is ammonia gas that is formed? So to confirm that it is ammonia gas that is formed, we need to place moist red litmus paper at the mouth of the test tube without touching the wall of the test tube. Why? If you realize, because before we warm it, right, they ask us to add sodium hydroxide. And what is sodium hydroxide? Sodium hydroxide is alkaline, right? So if we use a moist red litmus paper, touch an alkaline, what will it change color to? Blue. So that's why if you use a moist red litmus paper, touch the wall of the test tube, which might be stained with the sodium hydroxide that you add or you splash accidentally, then you'll be testing for the alkaline, not for the ammonia gas. So make sure that when you place the moist red litmus paper into the mouth of the test tube, make sure that you don't touch the wall. Otherwise, you'll be confused. Is this ammonia gas or is this the sodium hydroxide gas? Alright. So whenever we do any gas test, we always need to prepare first before we do the step. Otherwise, when the gas produced, right, we'll be a bit fumble or a bit panic, a bit stressed, don't know to wait for the gas to come out or to prepare first. So we prepare first. Alright, we prepare first. So move back to the question. So over here, they are asking us to test for ammonium ions. So if there's ammonium ions present, we should look for ammonia gas. Then we need to stand by moist red litmus paper. Okay, so how to gently heat, right? So if you use the test tube holder to cap the test tube and you heat it under the Bunsen burner, so if you feel a little tiny sensation like onto your hand, right, that means that you are gently heating it. But if you are boiling it, right, then you feel that the whole thing will splash out. That one is boiling. So you are asked to gently heat only. That means you should feel some sensations on your hand, like when you are gently heating the mixture. Alright? Okay, moving on. So in part 2, they ask you to add sulfuric acid and add potassium manganate. Okay, so what is potassium manganate? Okay, so potassium manganate is an oxidizing agent. Okay, so you notice, right, redox can also be tested in practical as well. So for oxidizing agent, that means that it's used to oxidize something in the process. So in this case, if something is being oxidized, the potassium manganate itself will be reduced and will change from purple to colorless. So I'll leave it to you to observe. And they ask you to add slowly. Slowly means you drop by drop until you see this permanent pale pink color. And this is solution Q. And you need to retain this one for use in the next part. And next, let's do the next part. They ask you to add aqueous ammonia with shaking until no further change is seen. So you see no further change is seen means adding excess. Okay, so let's look at aqueous ammonia. What is aqueous ammonia? What are we testing for? So let's look. Okay, so aqueous ammonia is also a type of alkaline. So when it's aqueous ammonia, we are also testing for cation. See, aqueous ammonia. Alright, so we're testing for cation. So write down test for cation. Alright, so this is how you annotate your practical before you start the paper. So let's do this for every single practice and you'll definitely get the hang of it and you'll score well for practical.